Hi, good evening, everyone. Welcome to my talk of journey of adopting Elixir. As Paul mentioned, this is my first talk, so I'm sure I will get nervous and say something stupid. So just bear with me. Sorry. All right. So just a quick introduction about myself. My name is Wei, and like many of you from Ruby background, I actually have been working on Rails for a bit more than 10 years now. For the last 2+ years, I moved my focus a bit to the ops/engineering side as a previous company moving stack to the Kubernetes. So currently I'm working for Archive as a full-time developer of Elixir. David here is my boss. About this talk is about the journey of adopting Elixir, and I'm actually referring to my previous company, HiveTech. This is how the company get chance to know Elixir, and then find a chance to get applied into the production. And also there's something I learned, tips and tricks and challenges along the way. So this is the talk about. The disclaimer is first off, I want to thank my CTO Robert from HiveTech that he actually encouraged me to give this talk. And second, this journey of adopting Elixir is sort of my personal journey, and also is also my journey of learning Elixir. So most of the approach and practice may not be the best one, and I'm sure. So feel free to give feedbacks and suggestions. I'm happy to learn something new from you guys. So a little bit of background. My previous company, HiveTech. So we are a small Ruby shop. Our customer is multi-tenancy in our production system. And we do have a very heavy third-party integration and data exchange between our system and the in outside servers. A little bit more on the technical stack. We use Rails, like many of you guys, and we have a customized background drop system in both Ruby and Node.js. And we just finished a transition from a not so standard Dockerized environment to Kubernetes. So how we get into Elixir? It actually is introduced by my ex-CTO, Igor, who is an active member of the Elixir community as well. I still remember one day he came to me saying he's learning a brand new language and telling me how cool functional programming is. And not before long, he's starting work on the very first Elixir prototype of our company, which is a background drop dashboard. Back then, it's still old. So what we use is Elixir 1.12 and Elm for the front end. Pretty much like we have multi-tenancy, so we need a sort of a central drop dashboard to see the drop status across the different tenancies. So pretty much like he have the workers to fetching drop status in the backend, and then using channels to put the data to the front end. I was impressed right away, and then start to get into learning Elixir as well. I'll have to admit it is a bit of a learning curve as well, but always thinking of besides on doing all these to-do apps and stuff, how can we just make it to use in our production as well? So not before long, and we finally have the chance. So moving forward, there's a chance that as business develop, there's one third-party integration that we need to do, which is a third-party API, like most of the you guys like encounter very often. So this is pretty standard OAuth integration. So we pretty much need the access token, and then get authenticated, and then the follow-up API calls to fetch the resource. there are some requirements for the access token. Say if the access token, the lifetime is 60 minutes, then you cannot do a refresh token before 30 minutes. They just don't want the people hitting the authentication server that hard. So for the challenge of us is both web and background job system need to be connected to the API. So that means both more than one server need to get authenticate and then call the API. So then we have a brainstorm in our team saying, what should we implement this job? So as you can see, so we have the web server and the background job server. And this is our internal system. The cache is just simple. So it could refer to Redis or database. And for this to work, say we will have launch background jobs first to fetch the API token to the auth server and then get back to the access token. And then that means we need to store the access token to some sort of cache or database, or say Redis, for example. And then both web and the background job server can fetch the token and then make API calls to the API server to fetch the resource accordingly. So this is one way of doing it, which is implement the OAuth within the Rails code base. So there's a pros and cons about this approach. Say it is pretty straightforward, and single change in code base will work for both web and the background job service because they pretty much share the code, same code base. But there are also con sides of it. So say, for example, because the access token need to be shared between different servers, that means you need cache or DB to store it. And then you need to configure extra jobs to fetch token. And also you need to refresh the token as well. So lastly, it is tightly coupled. If we implement this in the Rails code base, that means it is lack of the ability to extend to other services. So then we make a decision to extract these services. So we want a single service that handle this authentication. And then within the cluster network, and then no extras, when you say no external ingress is needed, that means outside world cannot access this authentication service because we haven't configured any ingress for it. So that means it is internal use only. And then this separate service can serve backend jobs, and potential it can serve more service in the future. So give an example of this is if we implement with directly with Rails, that means we will somehow get the access token first, and then make an API call to the say like API resource, whatever. And along that, we need to embed it the access token as bear token in the headers. But with this service, that means we can forget about the bear token when we call the API. So we just call it locally as if it is like a service without authentication for the caller. So this is like a diagram that compared to the previous one. So the background job is the same, and also the external services, but we will adding an auth proxy here. So firstly, the auth proxy will injecting and generate all these HTTP token requests and all the required headers, and then you send to the auth proxy, auth server, and get back to the access token. And then we will save it into ETS cache. And then this auth proxy is self-contained, like it is fully sufficient by itself. That means it can receive any call from any other caller, regardless whether it is a web or a background job server or any other new service in the future. So the background job and web will call the API to the auth proxy, and the auth proxy will call the original API server and then forward the response to the caller. So when we're choosing the stack, and I was keen to use Elixir because I want to give it a try in the production. So the way OTP give it advantage of this is it's so easy to handle all these background jobs. Say if we want to have an call to fetch the API and refreshing regularly, we don't need actually any third-party API third-party libraries. We can just use the process.set after and then define interval, and then we can just refresh the access token using this method without any extra libraries. And for caching the token, we're using CacheX, which underlay is using the ETS table, which is, well, I would say is a drop-in replacement for Redis for at least most cases. So the outcome of this service is very good. It just simply works and very fast. A good thing about extracting the services is it can be maintained and deployed separately. If say there are more endpoints added in the third-party APIs, then we can just modify this one service and then it will work right away. Because itself, it is extendable. Like in the potentially, we currently caching only the access token, but in theory, we can do a lot of modifications. Say, for example, if there are some frequent API calls or very large API calls, that we can cache the response in this proxy and then return to the caller directly. Of course, you can need to set some time interval, that kind of restriction, but that means it is that in that case we can save any calls to API and get faster response. And the Linux application is very low resource consumption, which is compared to Rails, it is like just way too much. And the most important thing is because it is self-contained, that means it can be called by other consumers. This is actually the biggest benefit of this extracting service to Elixir, because not before long, we have new requirements from our business department. Because one of these API endpoints actually provide meta raw data. So our business department decided it would be good that we will fetch all the metadata and then put it into a database data warehouse project. And we can hook it with any like BI tools like Power BI or Tableau, that visualization tools. In that case, that means we will need another service that act as an importer for those raw metadata and also provide a main GUI for the user. So as you can imagine that this new importer service, the step we choose will be using Elixir as well. So this we talk to the auth proxy that we just built before. And then the requirement is, say we have like more than 50 types of CVC daily cross-tenant need to be imported. So say every midnight, 2 o'clock, and the third party will be generating this CSVs, and then we have a cron job to kickstart it to import this like 50 types of different CSVs. The step we choose is still Phoenix. I would say writing importer using Elixir is like it just makes sense because functional programming is like very good for processing data. So you can see, when you write a code, you can always have a mindset saying, okay, the data is flowing from this way of the pipeline to the next stage, and then the next, and the next, and then finally to the end of the process. So so the way I write it is like I used to want to write all the pipeline from the beginning to the end, but now I would say I would use more with statement at the moment to catch more exceptions. But that is this project is like in the early stage of writing Elixir, but still I think the approach is pretty good because when you see the pipeline, it feels like pretty straightforward. So that is I think the beauty of the functional programming. So for this new service, we use contain jobs to trigger the import, and we use Gen server to handle the trigger. Because the mailbox of Gen server, it is synchronous process, and we are handling more than 50 CSV import per tenant. So in order to not block the message box, so I move the actual work when we handle the Gen server to the OTP task to avoid blocking. And also I use a library called Touch for the GUI GUI interface. So the good thing about using Elixir for importer is like it has a native CSV library, which using streaming function by default. So it is processed per line and get a lazy evaluation that lead to very low memory consumption. There's some tricks I find along the way. So on stream object, it has a function called trunk array. I'll just go back a little bit here. So so when they load the CSV, we can stream and trunk trunk area, the trunk size you select. In that case, using this with the Ecto insert all will be greatly improve your efficiency. I do a comparison. If using a standard stream.map plus Ecto insert, say like a big CSV, say for example, takes 2 minutes to import in my local, but if you use trunk vary and combine with the import all, it takes less than 30 seconds. So that is a huge improvement in terms of speed. Also, I did a lot of testing to see what the trunk value should be. So start with 10 and then 20, and then when I up to 100, I think I got a reasonable amount of time to finish. Say if even I increase this value to 200, it doesn't make any change differences. So that's something I learned in a way. So I probably need to give a little bit basic concept about the platform, which is Kubernetes. I believe it is the de facto standard for the offsite at the moment. So pretty much it is a orchestrator platform for manage your containerized application. So for pod is the smallest unit that you pod is the smallest unit that you deploy on the platform. Deployment, it's a declarative updates to manage the whole step. Say for example, if you have 2 apps, that means likely that you will have 2 deployment. And then in Kubernetes, there's a concept of jobs. Jobs under the hood is still jobs, still pods, but it is like similar to cron job, so it get executed and it will get terminated. Alongside, you can configure that either you want to run it as a cron job or a one-time execute. Liveness and Readiness Pro, it is related to health check. Say for example, if you deploy a new version of your application, and then the way it handle it is it clean up the new one, but it didn't shut down the old one first. So all the request is still falling to the old one until the Readiness Pro saying, okay, the new pod is ready to serve, and then Kubernetes will switch off the old one and then routing all the requests to the new pod. So this is some basic concepts. The first thing I will encounter about my application is health check. Say it is a good practice to define health check in any Kubernetes system, which means that if it doesn't get for this example, say every 30 seconds, the Kubernetes will ping this slash health check path to see if it got a 200 response. So if it doesn't get within like 10 seconds, that means this pod is crashing internally, that the Kubernetes will restarting the pod. So this is health check in general. So the most easy thing to implement is, okay, if that is the case, we just define a health check controller and then just respond to the health check ping from Kubernetes, which is fine. But one problem is it will generate a lot of noise in the logs because any request access to the Phoenix, it will have a log. So just imagine that you have every 30 seconds, you have 2 lines of these logs, and then not before long, you will have like pages of this useless health check. So that's why I decided to find a way to turn it off. The thing is, putting the log false doesn't really work in this case. So I just do some more research and ask questions in the forum. Finally, I got a solution. Actually, you need to create a plug that pretty much do the same thing as the controller. So we have a pattern match on the request path, say the health check, and then send back 200 OK and hold the connection. And then you will need to put into your application web endpoint pretty much the very first line of your prop above any other else. So in this case, it will sort of override any mechanism at the back end to run in the logs. So that is a trick that I learned from this app. Also, migrations, which is an interesting topic. So I'm not sure how many of you will write the first attempt. Like when we execute in production, we just execute echo migrate and then echo server. That's what I did at the beginning. But as following the same approach as deploying Rails, so we decide to extract this into separate process. So we will, for migration, we moved it from the normal production deployment pod to Kubernetes jobs. So we have a different execution command using jobs. There's a pros and cons about this one. I think it's a good, probably it's a pros. So why do we need to separate the pod process into the other than the deployment? Because separate the process can have a different type of deploy cycle. Kubernetes deployment is clever enough to say if you have a job fail on the pre-deploy stage, and then the follow-up deployment won't continue. So you don't need to worry about what happens if the migration fail. And also separated the process. That means you can have separate control on your migration process and your normal, say, Phoenix web process. So you can, because it's 2 configurations, so you can allocate different configs for the logs, metrics, and even exception aggregator. Say for my company, for example, we use Sentry for the exception aggregator. So we actually split different environments for that. So we will have a project saying allocate to migration. We have a project allocate to the web server and another one for the background job. So that when you separate it, it's easier to catch different errors in different configuration. So it's cleaner to see. Also, by shipping the migration to the jobs, that means you can have different images. And the good thing about that is, to be honest, like for this particular case, probably not different much. But for, say, for example, for the real side, that is different because for most of the time, you don't need complex system libraries for the web server. But say, just imagine that you have a Sidekick backend job server that you need to process the extra images or need to install Chrome driver. That means you could have a different Docker images, one for the web, and then on top of that, you can have one adding more system libraries like you process image or process PDF, whatever, and then you have another image for the background system. That actually is easier to deploy different images to different type of jobs. Lastly, you can specify different resources. Say you could allocate like 4 GB of memory for your main web application, but for DB migration, you don't need that kind of memory. So I can allocate like 500 megabytes of memory for the job, so I don't waste any resources. So this is a benefit of try to spread the migration to jobs. So at some point, we really want to get to the try to use the mixed migration, actual migration, and mixed Phoenix server to the mixed release, because in production after deploy, it's just taking too long to compile, even after you deploy it to production. So the good thing about move to mixed release, it is like reduce the time that you spin up your new production release. For us, this case, we have like reduced from 30 seconds like to less than like 10 seconds. So lastly, I guess is multi-stage Dockerfile. So say if you have one single stage of Dockerfile, then you're likely to have a very low CI pipelines, because whatever change you make, that you likely need to rebuild your Docker images from the ground up. So I think the current practices is try to split the stages to multiple stages. So each stages, usually CI is cached. Say you could have a stage to basic Elixir, and then the other stage to SS, which is JavaScript, and then the final release is going to combine these two. The good thing is any JavaScript code you roll should not affect the build time when you're building the Elixir stage, and vice versa. So so splitting the multi-stage, we can greatly reduce the build time in the CI. So it used to be like 1 minute or 2 minutes. Now we can reduce to like 30 seconds, because for most cases, because we didn't change that, we didn't change JavaScript that much, so we mainly changed the Elixir code. So that means we only need to change one layer when doing the Docker build. So the other good thing is this by doing multi-stage Dockerfile, we can greatly reduce the Docker size from like more than 60 megabytes to less than 20 megabytes. And that actually improved the build CI speed as well, because Docker image pull and push also takes time. Talking about performance and resources, Elixir is just dropped, right? So we can just keep testing how many resources that we should have. We also, I have to admit that we do over resource at the beginning, but as we test more and do more combination, then finally that we come to the reasonable configuration for how much CPU and memories that we should allocate to these particular services. And also, thanks to the Erlang Beam, say it doesn't require that much CPU, because Beam's scheduler have a extremely efficient CPU content switching. So even the CPU, say before I have we have a cap on one CPU and most, and then we just request 1/4 of the CPU. But you can see even the CPU usage is way above 1 and get capped. And also you can see the CPU when it goes to 100%, the CPU is actually more than the limit here. the limit is 1, but it doesn't have any effect on the process running thanks to the Erlang Beam scheduler. For normal Phoenix app with a heavy data import, you can see the memory usage. Maybe it's a bit hard to see, but it's less. It's around 200 megabytes for memory. That is a lot less compared to Rails. So this is a diagram from Elixir in action. So when first time I see this diagram, I didn't feel that strong. Like, okay, everything Erlang, so what? But actually, when you're running apps in Erlang/Elixir, then you can feel the power of the Erlang OTP, the Gen server, and the way they process requests, and also the ETS table make it easier to have like drop-in replacement for Redis. So it is like self-contained. You don't need extra library or services to spin up to support you. So that is something that after you implement it, that you realize how powerful the Erlang Beam OTP is. So lastly, overall conclusion. So I would say it is a reasonable learning curve, especially for Ruby devs. Although its syntax is the same, but in terms of thinking, just like Ruby, you are thinking in objects, and Elixir, you are thinking in processes. And also we have fast development with the framework. Phoenix itself is very similar to Rails, so it is extremely fast to get some prototype up and running. And it was very high performances. Because the process is very lightweight, so I actually spin off like more than actually spin up all the 50 CSV import at the same time with some interval in between, but it just performs so well. Also, the good thing is also the Elixir has very low resource consumption, as I just showed in the diagram before. So even I give you like less than 1 gig of memory and 1/4 of the CPU, it doesn't matter, and it will perform extremely well. And also, the lastly is like you have confidence with the old Beam OTP, because like even that if something if I screw up, like okay, something is taking 100% CPU, but you will know that it won't get blocked. Other service won't get blocked by this 100% CPU process, and everything else is still performed nicely. So that is something very impressed me. So by the end, the company has like 2 to 3 service written in Elixir, and I really hope we can keep growing. So overall, this is a very good experience for me. All right, this is my talk. Thank you so much.
Woo! Thanks, Wei.
Awesome. Thanks very much, Wei.
I look forward to all of those exciting things being added to our Kubernetes setup. I've got to say, Wei's working for us now in a different company, and we have none of that. We're rapidly, screamingly, urgently trying to catch up on all of these things. So, thank you, Wei.
Okay, any questions?
Yeah, I've got a question to follow up on the Kubernetes side of things. Did you just sort of have to figure those sort of patterns of how to best to use Elixir with in Kubernetes out yourself, or are there resources out there to learn this? Because yeah, I've definitely seen similar patterns used in other in other sort of in other setups, the multiple Docker image layers and the pattern of running migrations in different different pods, etc. But yeah, did you sort of just figure that out, or did you are there resources out there? Because I think it's big. It's a big learning curve, isn't it?
Yes. Just say after we spent like almost a year and a half to migrate to Kubernetes, it is because of the policy reasons that we need to self-manage it, which is extremely painful. So the first thing I would say is don't do it. If you want to go for Kubernetes, just get EKS or Google Cloud. Don't manage yourself. It just unless you have a very experienced ops, but experienced Kubernetes ops is hard to find and extremely expensive as well. So the good thing about Kubernetes is it actually erase the barrier of differences of different languages. Say to me, Elixir, it is the same. It doesn't difference with Elixir between Elixir and Ruby or Node.js app. We will try to follow the same approach. The approach I use in Elixir, it is partly because that is what we use for Rails, and like Phoenix is sort of similar to Rails, so we follow that's why we follow the same approach. Some say the approach is sometimes overkill for this small Elixir app, but we just want to try to do the correct practices. To be honest, like there's some people say Kubernetes won't be the best platform for Elixir because Elixir itself has a very powerful way of expanding itself. Like you can join the cluster, and you can spin up thousands of processes. But the way Kubernetes works, or the concept of it is, you are not trying to scale on the language level. You are trying to scale on the platform level. Say, for example, if I spin out a web server for Ruby, and if I want to scale, I just spin up another one. So I just make a replica to 2. But if we do the same thing for Elixir, that some people would say kind of waste of the capability of Elixir, because say I don't need one CPU core surface. Just give me a 2 core surface, and I will use all of them, right? So that's some people have their opinion, but just for sake of the whole company stack, I think the Kubernetes is still worth it, I would say. There's some debate about should I implement Kubernetes. I would say it really depends on your cases. Say you can go to Heroku and then just forget everything. But if your company have like a lot of small surfaces, and it might worth to look at using Kubernetes, because just my personal opinion, just like Rails, right? So people say Rails is heavy, let's use Sinatra, but it end up that everyone have their own version of like add-on Sinatra to be more like Rails. So they're better off just using Rails at the beginning, rather than have some heavy added version of Sinatra. So my personal thinking is it probably have something similar to a Kubernetes as well. I agree that it is very heavy and it is like very huge, and it probably overkill for most cases. But if you don't use it and using some of your own implementation, then it end up like try to implement your own version of Kubernetes in your own way. So that's my 2 cents. So it really depends, and you need a very good ops for implementing Kubernetes.
Sure.
Awesome. Thanks very much. Anyone got maybe one more question?
I have one way. Especially at the beginning, can you share with us what was your strategy for testing?
That's something I'm not too proud of. That for these two services, it is pretty straightforward, and then I'm still in the learning curve of learning Elixir. So I actually don't have much test written for these services. But yeah, you should be writing more more testing in this case, because for the first one, the proxy pretty much forward the request. So there's not much business logic to test. So that's why I don't bother to write tests in the first place. But for the second one, the data importer, I do write some tests because different CSV, they have different data type in the database. So you need to pre-process it before you insert it to the database. So for that part, I wrote some tests for it. Is it okay for your question?
Yep, thanks.